Let's talk about what's in store for the universe as we explore cosmology, the future. Recall that Hubble and Humason observed over 600 distant galaxies, and they determined that not only were they moving away from us, but the further away these galaxies were, the faster they moved. The relationship between the distance to a galaxy and its recessional velocity, the velocity with which it is observed to be moving away, is a remarkably straight line. Now, this remarkably straight line can be seen in a graph of the Hubble or Hubble Lemaître Law, also called a Hubble diagram. Observations prior to 1998 showed that the expansion rate was a constant. In other words, the graph relating the recessional velocity of a galaxy to its distance was a straight line. However, astronomers did not expect this line to be completely straight. They expected the data at the upper right corner of the graph to start dropping, lying below the projected straight line. And as is the case with any set of expectations, there is always the reality of the situation that we must consider. You see, astronomers believed the universe had been expanding more quickly in the past and was now expanding more slowly, since gravity must be slowing down the rate of expansion. Or so they thought. This is what they expected to see, that the expansion rate would slow down at the furthest distances, leveling off below the projected straight line. But this is what they got. Instead of slowing down, the expansion rate is actually speeding up at these furthest distances. So, what's going on? To try and answer this question, two teams of researchers began analyzing redshift data of type 1a supernovae because these are ideal standard candles for observation. The teams were the Supernova Cosmology Project, which is still operational, and the High Z or High Redshift Supernova Search Team. In 1998, the High Redshift team became the first to publish observational data of these type 1a supernova redshifts using the Hubble Space Telescope, and they showed that the rate of expansion of the universe was actually increasing. The universe had always been expanding, more slowly in the past, but now it's expanding faster. This Hubble diagram, a diagram comparing distance of galaxies to their velocities, or any variation of these parameters, shows the data from the Supernova Cosmology Project, which, similar to the High Redshift team's data, also showed that the expansion rate of the universe is increasing. Now, how did either team come to this conclusion? Because their data ended up above the straight line that would have represented a constant rate of expansion of the universe. Data points that trend upwards indicate an increasing rate of expansion instead. So what is going on? Well, I'll tell you what's going on. It's some Nobel Prize-winning stuff, that's what. In fact, the 2011 Nobel Prize in Physics was awarded to select team members of the Supernova Cosmology Project and the High Redshift Supernova Search Team for their discovery of the accelerating expansion of the universe through observations of distant supernovae. Now, this raises some really interesting questions. First and foremost, why is the universe expanding faster? Well, frankly, we just don't know. Not yet, at least. But we can tell that there is something that's causing the universe to expand faster now than it has been in the past. Our current hypothesis for this is dark energy, which is a repulsive force that is responsible for the acceleration of the expansion of the universe, and a concept that we'll dive deeper into in the next video.